Now Boshun is going to present. He just finished his PhD on the topic of Chinese historical constellations and star names last year. And welcome. We are excited to hear. Yeah. Yes. Wonderful.
Hi everyone. My name is Boshun. I come from the University of Science and Technology of China. Many thanks to Dr. Hoffman to invite me here to this nice meeting. And I would like to share part of my research. I've just finished my thesis this June, and I will share the reconstruction of the Chinese constellations and their historical changes. Firstly, I would like to give a simple introduction about the Chinese constellation history. As it's well known, the stars on the sky indicate seasons. So some of the stars have been observed by ancient Chinese people from the remote antiquity. So the oldest star names that we can find are the four star names in the book of the canon of Yao in the book of document. The Emperor Yao is a legendary emperor who lived in 4,000 years ago, and the canon said the stars are observed by his ministers, which should not be true. But most scholars think the texts are a set of the real observation, and according to the research, most of them are observed in about 1000 BC. So those star names should be observed, should have existed more than 3000 years. And after from the 1000 BC to 1500 BC, more star names appeared, and most of them are the members of the later 28 lunar mansion. And since these classics are not specifically about astronomy, so I think these names should not be complete. But at least in the 5th century BC, the complete 28 lunar mansion has appeared on this lacquered box from the tomb of Zheng Houyi, who lived in the 5th century BC. As you can see, these are the characters of the 28 lunar mansion. They're surrounding the character of Dou, which means the Big Dipper. And it was exaggerated. It strikes a point to the four important lunar mansion. The lunar mansions are they served for the motion. They served as the reference points of the motion of sun, moon, and the planets. So they are very important in calendar making. What about other? This 28 lunar mansions was divided into 4 groups in ancient China. As you can see in this book, this is the white tiger and the azure dragon. And apart from the tiger and dragon, there's the red bird and the blue turtle. The 28 lunar mansion and the four animal, which is called 4 images, are the most important structure in the ancient Chinese constellation system. From the 5th century BC to 2nd century BC, more star names appeared, but not much. So we are not sure at which point the intention of constructing or naming the star name, the constellations of the whole sky appeared. But at least in the 2nd century, we see in the Book of Celestial Officials, which means constellations, which wrote by Sima Qian, the Royal Imperial astronomer in early Han Dynasty. In this book, he mentioned a constellation system that consists of 85 constellations and more than 500 stars, far exceeding the previous texts. So, and he said he learned these constellations from the famous astrologer Tang. So it should so this constellations should be regarded as Tangdu, belong to Tangdu. So in this text, the whole sky was divided into 5 palaces in the central and northern, western, southern, and eastern. But more importantly, I think this monograph has determined the basic layout of the later Chinese, the later structure of Chinese sky. For example, in this monograph, he set up the purple palace around the polar region, and the bright star Beta Uma is regarded as the emperor, and Alpha Umi is the empress. And the stars on their side are the sun and concubines, and these stars surrounding them are the guardian ministers who need to protect the safety of the membership of the family of the royal family. So and it's clear that from this monograph we can see the intention of constructing the whole sky as a celestial system. I mean, constructing the whole sky as the counterpart of the terrestrial imperial state. So the constellation, they are not unique constellations. They are together to form a society. So everyone, they believe that everything on the land are governed by some stars on the sky. So in such belief, more constellations were created. The Tangdu system was later developed into a new system which consists of more constellations and stars. And besides of the after Shi school system, other schools, for example, the Gan, Wuxian, the Yellow Emperor, and more were also developed. And in the 3rd century, an important astronomer whose name is Chen Guo, he sorted out all the constellations from different schools, and he picked up Shi, Gan, and Wuxian school, and organized them into a new system, which consists of 283 constellations and 1464 stars. This system was adopted by the later dynasties for more than 13 centuries. So it's the most important system in imperial China. So what exactly did Chen Duo do? I found it was a complicated job, because the different schools actually their constellations conflict with each other. The Shi school constellation are the most bright stars. So the later schools fill in the gap between them. And I found that the yellow emperor, some stars, for example, the female direct and born, they late between the night and here, and then this should be a conflict with the Gan school constellation, the celestial street and the moon. And another example, the astronomer whose name is Simon in Han Dynasty, he mentioned constellation farmland, and it exactly at the same place with the Gan school constellation. So Chen Zhuo must have removed all the constellations that conflict in the same place, and then they found the new constellation. We can compare I mean, this is the original system of Tangdu, and the new system. The new system has much more constellations, and they are from the Gan and Wuxin's school, and they are more faint, and they fill in the original simple framework very perfectly. This is the royal palace, and more officials over the staffs of the emperor was added in, so they fit in very well. So the Chinese constellation system is a complete system which is comparable to the one which derived from the ancient Egypt, Babylon, and Greek. But at the end of the Imperial China, means the official astrology career come to an end. So the star names becoming less and less known. So the previous scholars have done much work to reconstruct it. As you can see, this is the one restored by Professor Yi Shitong, which is the most famous one because it's used widely by the astronomers and the amateurs. But actually, this system is restored based on the data compiled in the 18th and the 19th century, which is converted from the Flamsteed star table. As we know, since the introduction of the European astronomy into China, the Chinese constellations have changed a lot. Many constellations were deleted, and some are transformed, and a lot of the fainter stars are added in. So it's completely different from the original Chenzhou system. So this constellation not only stands for the sky in the 18th and 19th century. So Mr. Pana had pointed out this clearly, and he used the data observed by the astronomers in 11th century and the star maps to reconstruct the system of the sky in Song Dynasty, much reliable. And Professor Sun Xiaochen also tried to reconstruct the sky in Han Dynasty, which is maybe 100 BC. But he only had at that time he only had the observing data of the Shi school constellations. So for the Gan and Wuxin constellations, his reconstruction is not so reliable. So there's always a lack of the reliable skies before the 11th century. So that's what I did. So what did I do in my reconstruction? Firstly, and most importantly, is the star observation data. Luckily I found 3 new ancient star catalogs, and the most important one is the first, because it it is observed by the astronomers of the Shi, Gan, and the Wuxian school of the Han Dynasty. So it plays a role, a key role in the reconstruction. The position of the Gan and Wuxian school actually are not as precise as the Shi stars, but at least it's enough for me to locate the rough to know the rough location of the constellations. And the second kind of resource I use is the early star maps. These are the most ancient star maps, Chinese star maps before the 10th century. They are to some extent neglected by previous scholars because it is preserved in Korean and this is preserved in Japan. They coincide with the data observed by the three schools very well, and they have some in the shape of the constellations. They have many similarity and different from the shape of the later dynasties. And the third kind of resources are the early descriptions of the text about constellations. The most important is the star camp of Three School. It's believed to be organized by Chen Duo, and as you can see, it gives the rough location of the relative position between stars. For example, this is on this constellation is north of this. And it is consistent with the early maps and the star catalog. So I combine the three kind of resources together to reconstruct the constellations. They can support and make up for each other. Let me take an example. This is the Chinese constellation Fuquang, which means basket for mulberry leaves. And in the construction of the 11th century by Mr. Pan, the location is at that place, but the observing data by Gang school is located here. So it's different from this place. So I checked the star maps, and the three star maps doesn't support this place. So I turned to the text for help and found some very interesting clues. For example, firstly, the Gan school said it's in the north of the Tianjin, the Celestial Bridge. This is the Celestial Bridge. It's exactly at the north of it, and this is at the east northeast. So this text supports the data, and the Shi school and the Jingzhou divination. Also, they referred to the bright constellation, the Weaving Group, the Vega. And at the Shi school side, the way of the journey in the Weaving Group is aligned with the Guansu, the coined throne, and its food points to Fuquang. And the Jingzhou divination side journey points to the Qianniu, which is leading the ox, and Fuquang. Okay, let's check. So the way of journey is aligned with the coined throne. Yes, that's right. And this points to the right foot points to this Qianniu leading the ox. That also correct. So the left foot points to exactly this place. So that supports the data also. Actually, I found another clue in the book compiled in the early 8th century, and the observer side, the basket is at that time is at the mention of Xun, on the old map. I mean, the old map is before 8th century. The old map is on the Xun dimension, and but at the 8th century, it's at the mention of those. So the old map also supports this location. So that supports the location and very strong. So okay. So this is the constructed the oldest basket. Okay, in this way, I constructed the oldest constellation of Chengdu system. And in a similar way, I also constructed the star maps for other three epochs. And by comparing them, I found something very interesting, that the constellations actually changed a lot. That is very different from the view of the previous scholars. Okay, and I made a count, and I found the ratio of the changes, even in the system Chengdu, it changed about more than a half. I mean, only with the four skies, which is restored based on the star catalog, star map, and the text together. If we count more star maps, the changes are much more. So first, the changes can be divided into three kinds. First is the relatively location change. For example, the Gans who said that the four constellations, Simi, Silu, Sui, Sufei, is the motion of the Xu constellation one by one, and in this year, suddenly it changed to the two constellations changed to the left of Xu. So it become different, and the shape difference. For example, the January and the Thunder. This is the earlier January, and this is the January after the 11th century. They're totally different, and the Thunder also. There's no similarity between them, and there's some minor changes. For example, this is the water level, and they are almost at the same place, and the shape didn't change much. So I think this is common to the ancient observers if they did not pay much attention. So how did why it's changing so much? I want to find the reason. Okay. Firstly, I think there are some observers that made a mistake in the observations. For example, this is the star, the constellation Ping. It means the horizontal level of justice. It consists of two stars at nearly the same latitude, the R and Y. But the left star is a variable star. It can change from the magnitude 3.5 and 10.9. Okay, at its brightest, it's comparable to the red star, but at its faintest, it's invisible. So I found before the Song dynasty, means that before 12, maybe 11 or 12th century. Before that, the observers know the nature of this star. So in each observation, they always selected the right one, the correct one. But At the observation in the 14th century, I think maybe at that time the R are invisible and they select the pi instead. So I found after this year, the star maps began to draw in this shape. So from the horizontal to an inclined line. That's interesting. So another reason is for the wrong identification is inaccurate star maps. I mean, a lot of people think the Chinese ancient Chinese Chinese star map should be accurate, but I saw this is the image from the Suzhou star map. It is regarded as one of the most accurate one. But I found on this map there are a lot of constellations that have they are actually different from the real shape on the sky because it's regularized and it's much more circular than the real circulation, than the real distribution. So that's why as I know, the ancient Chinese observers they do not observe all the member stars of the constellations. In most cases, they only select one, the key stars or the most bright star. So when the astronomers draw the star maps, firstly they will draw the star with the that have the coordinate, and then they will draw the other star points that according to their memory. So and then connect them with the hardline. So in such a process, some of them may have been, I mean, the shape may be idealized or have a tendency to be to display a perfect geometrical shape. So this kind of tendency of the star maps will have some influence for the observers, especially those these learners who strictly follow the star map. For example, this is the constellation extended at one of the 20 dimensions. In most the source star in the middle part should be this star because it's the brightest, and the Suzhou star map had captured this location information. But most stars tend to draw it as a regular diamond. So in the observation in the 14th century, I found that they select the fainter stars. Even this much more fainter stars will only 6.2 magnitude, and to match the star maps. So that's also one reason. And apart from the previous, and there's more. I mean, the locational and the shape changes. They're more serious. So I think this is due to the errors in transcription. Okay. For example, this is the inner stack. At first, it should be inclined because because it is the Gan school astronomers have created this after the Shi school constellation three steps, and this is similar to the Indian, yeah, and so it's inclined. but as you can see in the later, it's just rotated by a certain angle, and it becomes horizontal. And there's some more serious changes in shape. For example, this one at the first it's like like lambda, and finally it become a W. Actually, it's become the later. For example, this at first this is the correct one because the Shi school said it is similar to the constellation net, and if you turn it around, it will be similar. So and after it becomes the shape, and in the star map it turns an angle, and then it becomes wider, and later the two stars at both sides going upwards, and then more upwards becomes down. So that's why that's the process. And finally, I want to say that in this reconstruction, the meaning is for we should construct the skies for different era. That because it is useful for the study of the ancient astronomical documents such as the supernova, the shooting star, or the comets. For example, this is the Jingyu. It is the rubbing stone in 1034, and then 18 years later, it is removed. It is moved to this place. But if you there's a document of a shooting star. It said the shooting star begins at the north of this Pleiades, and it passing by the road tongue, and reached the rubbing stone. So this doesn't fit this document, and this is correct. And there's a comet document that previous scholars found very very strange. Okay, 1 minute. So firstly, it appeared in this Wuche constellation in May 26, and then 24 days later, it is close to Baku. And then another 20 days later, it's 2 degrees. It's 2 degrees from Sangong. So this document is very strange because it takes a turn. The comet takes a turn, and secondly, in this interval, it takes 24 days, and this only takes 20 days. That is very strange. But in the sky I have restored, that makes sense because as you can see, the later Sanshi constellation actually it's also called Sangong before the 10th century, and the Baku is much larger. So from this point to Sangong, it coincided perfect. So that is just a simple piece, but it shows how important it is to construct different skies for different approaches. Okay, that's all. Thanks for listening.